Hello, on July 30th. Alright, let's see what we have today. July 30th. Bitwise OR of subarray. Oh, I hadn't done this before. Oh, that's surprising. Bitwise ORs of subarray. Given array, return the number of distinct bitwise ORs of all the non-empty subarrays. 5 times 10 to the 4. Distinct. All distinct subarrays. The number of distinct subarrays. Oh, okay. So, in total, we have however many that we can do, 10 to the 9, so all 31 bits, right? 32 bits. So we have to decide. So for each one, we can we know which bits are set, which bits are not set, right? So for all the set bits, oh, it also has to be subarray. Oof, it has to be a subarray. Distinct bitwise OR. That's too big. Right, 2 billion is too big. Maybe what we can do is, starting from the first one, how many distinct we can get. Right, so first one, 1, 2, 1, 2, 3, 1, 2, 4, all the way to the end. And then we say starting from the second one. Right, starting from the second one. I don't know, I'm just playing around. So yeah, A0, A1, A2, all the way to AN minus 1. How about we say, we know A minus A, ending at this, right? And now we have A minus 2, A minus 1. Ending at this, A minus 3, A minus 2, A minus 1. All the way to A0, all the way to A minus 1. Okay? Let's say we know this. It's like a suffix OR, right? Now I want to see everything that ending at here, right? Everything that ends at here. So I know about this. I want to know about this part. Right? Can we do this part fast and easy? So how many distinct are there? So for here, I know the number of distinct. right? Let's say for here I have, 5, 6, whatever the number is. I have these distinct. And I need to remove this. Alright, I need to remove this. Because by removing this, we know if it's going to be distinct. By removing this, we want to know is if it's gonna be a new value, right? If it's going to be a new value. Yeah, it's like if I know the number of distinct ending at something, then I want to say I want to add a new one to it. How do I know? Because the size can be big. Right? How do I know? I have to add a new one to it. Okay, I have a new one. And a bunch of previous. How do I know that or with this it's going to be a new value? Yeah, without knowing the exact value, how would you be able to know? But ending at 2, it is limited, right? But then if you want to add this, you have to relist the whole thing. That's not how we think it should be. I don't know. Let's trying something. Alright, that's this. They're all at different positions. Okay, let's try the other one. This is this example. So I can say, if you put everybody together, you have a counter of position 0 and a position 1. Well, I think this is position 0, this is position 1. This has 2 counts, that has a 1 count. How does this help? Well, it helps by... I don't think it helps. Well, how does it help? I don't know. Divide and conquer? So divide and conquer is based on the fact that when you divide, it takes on to solve. So the total will be on log n. Divide. I don't know what I think about divide and conquer, but if I divide it in 2, right? Yeah, I can get this half, I can get this half, but the cost is the crossing, right? You have the crossing. And what's the cost of crossing? Well, the crossing essentially is so you get the total here, you get a total here, and I want to merge it. Well, merge it means I have to take at least 1 here, and then take at least 1 here, and then extend and extend. Is this? So you're telling me the merging cost is on. The merging cost is on. It's not on because these two are the anchors, right? I can do this, this, this. I can do this, this, and this. I can do this. Yeah, I don't see it. I don't know. Any hints, Lord, on the topic? DP. DP. Yeah, the ending at this is this much, and then you have a new one coming up. So okay, I'd say DPI is the unique values of array all the way to I. Right? Now I want to calculate DPI plus 1. Ending at DPI plus 1. Right, ending at DPI plus 1. So ending at DPI plus 1. So I have a new value. So maybe I can compare to the previous value. Let's say these two are the same. Okay? If DPI plus 1 and the DPI are the same, then the exclusive or one more, there's no difference. Right? There's no difference. if they're different, right? If they're different, so I have the unique count. I have the unique count among all these, which means they're gonna exclusive all in this one. So essentially means I have a bunch of values, right, which exclusive all the one previous, and now we get to the unique ones. Okay, now I get to the unique ones. So now what I want to know is, because to get to DPI, I have DP, basically I have DPI minus 1, right? I have DPI minus 1, and these applies nums I, right? These, applies DP I minus I, they got to DPI, right? They got to DPI. Now we don't know what this one is. Now we have a new thing, which is a num I plus 1. So maybe what we can do is nums I or nums I plus 1. So they're giving you a new value, right? Now we can call it a t. So now the question is, what will dpi minus 1 t turns into, right? So a bunch of this or this get to some values, and those are unique values, right? So if they are unique, you OR something, it's bound to be unique as well, right? It got to be unique. If you are unique, you have a bunch of unique, and you OR something, and after you OR something, they shall remain unique. Because the OR process, like if a bit is 0, we don't change. If a bit is 1, if original is 1, you also don't change. If the original is 0, now you add a 1 to it. Right? Now you add a 1 to it. So you might actually decrease the number of uniques. You might actually decrease. That is true. Right? It might actually decrease. So from a previous count, I OR the current thing, and then it become a new count. So so there's a reduction. So if it's a reduction for this, now I add a new, basically, if this OR does not change the value, right? If nums I or nums I plus 1 equal to nums I, which basically just means there's no change, then it will still be the same. But if there is a change, which means at some position it used to be 0, now it's a 1, right? Now it's a 1. Then how do we reconcile? So at those positions it's supposed to be 1. I don't know. No idea. Let's check the answer. You gotta be kidding me. This is called brute force. Wait, hold on. Current is at most 32. Wait a second, what? Yes. At the kth step, say we have the result ik. Kth step in some set current. Then we can find the next current set by using this equal to this. This is based on the fact that current is small. Number of unique values in this set current is at most 32. Okay, why? Since the list is monotone increasing. Is monotone increasing? Huh? Well, the more you I mean, this is just like what we were thinking, right? We have, at the end of something, we have the whole set, right? The whole set. And then you move on to the next one, it just everybody will OR the thing on the set. And you're not adding 0 again? I think you should add 0 again. Oh, because you're adding this. This is essentially adding 0, right? So yeah. So now the question: why is this thing at most 32? Why is this most 32? So every time you're OR something into it, so the new OR, you have some bits set, some bits is not set, right? And you also have some previous values. So you OR, and mostly will set those positions, right? Those positions will be set. So every value you have before, those positions will be set. Those positions will be set. Because when you start, it's a small value, right? It's a small value. And then it grows bigger. Why the 32? Because each time you are OR, you OR with the same value. Okay, I understand this. Each time you OR with the same value. So you put those ones out. And previously you can have, gazillion different. And then put those out. Let's say previously, okay, you have tons of different combinations. Now this thing comes out and it puts out those should be set, okay? So those varieties are gone. But the rest still have the varieties, right? The rest still have the varieties. Well, we start from 1, and then and in this we have 2. Right, and we have 2. The next we might have 3, we might have 4, we might have 5. So the reason that you have 3, so But I think I can answer this question by saying, what's the maximum it can get? Right? So you start from 1, and then if you have 2, the maximum is 2. And the third one, the maximum you can get is 3. Right? The fourth one, like ending at the fourth one, the maximum you get is 4. All the way to number 32, the maximum you can get is 32. But then, the next one, the 33rd one, the maximum you can get, because the previous one, the maximum you can get is because when you, because the previous, like the 32nd one, right, the 31st one, ending at the 31st one, the maximum you can get, okay, the maximum you can get is 31, right, it's 31, but just once the 32 one is 32 is because the 32 one, when it add to the previous 31st, right, previous 31st, when it adds to that, everybody become unique, right, everybody's unique. Everybody's unique. So the previous 31st and everybody is unique. So when the 32nd comes, it is unique as well. Now the 33rd comes in. You're telling me it's not possible to create so like I have 1, and the second one, in order to make it unique, I have to fill in the places, the 0 bits, right? I have to fill in the 0 bits, then I can create a unique one, right? And the next one, I need to fill in the 0 bits to make it unique. So the best we can do is, let's say I start with 1, and the next is 2, right? I fill in the uniques. And the next is 3, and next is 4, right? We fill in the uniques because the first is 1, is a 4, then I don't hurt it, and there's 2, I also don't hurt it, and then because when you get everybody together, right? When you get everybody together, and you want to keep it unique, so you have to fill in all the ones. But once you fill it to 32, right? You just can't. You can't make more. So so gradually you will fill it up, right? Gradually you will fill it up. But there are a lot more. I think this is the part I don't understand, because you have 32 bits. You have a lot more values. Why the OR only ends at 32? Like why can't we have more varieties? Right? Or, and a different question is, if I have like a lot of varieties, when I OR more, the variety will decrease. Right? It will decrease. And why would it decrease? Like, okay, so in order to create new ones, I need to find a position where everybody is 0. Right? That's it. If I want to create a new, if I want to not just create, to preserve, all right, because I'm positive, right? So if I want to preserve the same. So if I want to preserve the same variety, my choice is to be a 1 that's an order 1 that has already been set. So then I can maintain the same variety, right? But if I want to increase the variety, right? Increase the variety, then what I need to do is I'm basically placing 1s in them, right? Increase the variety. I'm not talking about the number. I'm just talking about every single time I want to increase the variety. Okay, I want to increase the variety. So to increase the variety, you can add to the front. That can increase the variety, right? But again, there's only 32 bits you can increase, so by the time you hit 32, you cannot do it that way. So now you can say, okay, if I cannot do that, so like I have on my hand 31 different numbers. So yeah, I can put it there somewhere to make those 31 different numbers, right? 31 different numbers. And I can do one more to make it 32. Right, now I have 32 different numbers. That's the maximum you can get, right? If you're ending at the 32nd value, this is the maximum you can get. So I think the question is, can we get a 33 if we move one more down? And the answer is no, because when you move one more down, you can't create, you can, because you have something ending at that value, right? That's when you can create. Like everybody else, yes, I agree. Everybody else, you can now create more different values because it will always be whatever the previous is, right? Because you OR it. So the maximum is just those. But you can add a new one, which is yourself. So now the question is why yourself is, yeah, that doesn't make sense to me. Okay, that does not make sense to me. Like everybody else, yeah, I agree, but why yourself cannot be the 33rd different values? Because you're adding yourself, you're ORing yourself with everybody else. So you OR it, right? You OR. So if they have a different one, so now you will be different, right? You will be different. You'll be different. So in order to get to 33, right? In order to get to 33. So all the 32 has to be different, right? Which means the previous 32 and or yours to it, right? And those are different, which means yours is either hitting the ones or hitting the places with all zeros, right? That's the only way for it to be working. Okay, so let's say you hit all the ones. Now your ones are hitting all the ones. Now if your ones is hitting all the ones, right, hitting all the ones, and all of those are different. Remember, like all of those 32 values are different. Okay, we have different 32 values, and you want to make the current one maintain those 32 is different. So you OR it. So all the 32, they have, like, say, one position is all ones, and everybody else is different. Okay, everybody else is different. So now you say, I'll put just one of them there. Okay? Right. Because I can have different combinations to get to 32. That's very simple. Right? That's very simple to get to 32. And I have this as 1. And then you get 1 coming in. So those are filling, so those 32. And then you get a 1. Now it becomes 33. Right? It's like, well, it doesn't make any sense. Why is 32? I think I can give you an example. It's not 32. Right? Right? What if I have something like this? I have a 1 on the front, and I have 1, right? So they have like, and I have 1, 1, 1, 1, 1, and then all the way to everybody is 1, right? So this is, I believe this is 31 of them. This is 31 of them. Oh, 32, I can just do 1, 0, 1. Right, now this 32. I'm not sure if it's possible to create something like this, but it's not possible to create. Okay. In order to make it to 32, then this has to be the 32nd value, right? The 32nd number has to be this one. So everybody will have to have this one has to be set. Right, this one has to be set. These has to be set. So you have these has to be set. Right? Okay. And then you need some combinations of the remaining to make up. Which is, you can. You can choose different combinations in order to get here. I just need 32 of them, right? Is monotonic increasing. That is true. That is true. Any subsequent values that are different must have more ones in its binary representation. That's monotonic increasing. Any subsequent values that are different must have more ones. Not necessarily, you can have ones at different positions. Yeah, you can have different positions, but eventually, right? Eventually, you'll hit a ceiling. But that still doesn't explain why the 32. I still don't understand. You either do not change the number of ones in each number, okay? Or you increase the number of ones. If you do not change the number of ones, it's already in the number set. If you do not change the place of the ones, okay, this is a little bit clearer. Okay, hold on, let me think about it one more time. So you have a previous set, right? And then you are going to OR a current number. So when you OR the current number, you always make it bigger, right? You always make it bigger. So you either don't change the previous, or you're adding ones somewhere, right? You're adding one somewhere to make it a different number, right? To make a different number. So every time you're adding ones, and every time you're trying to add one, because if you don't add one, it would just be the original set. So you want to add one, okay? You want to add one. So when you add one, then, because the original is whatever it is, right? And you can change, but you're not gonna make it. Yeah, the only source of new numbers, like different number, is you're going to add a new value. Right? You're adding a new value. Yeah, you're adding a new value. Okay, so yeah, you add a new value, and all the previous values, and all the other values need to be bigger than that one, right? To be bigger than that one. So you're just, and they all have to have the same setup, right? Then you just, they have to be bigger. So you have to add 1 to some positions, right? You add 1 here, you add 1 there. Okay. And then you have to get a new value. If the new value has been encountered before, I still don't understand. The OR operation is always placing a new one. I think the key is you cannot rearrange the ones that's already there. I think that's the key. You cannot rearrange the ones already in there. Whatever's in there, it's set in stone. And your new value comes in. It's simply a new... You have to add a new one. Right? You have to add a new one. And if you don't add a new one, that's just the original one. If you add a new one, okay, you get a new value. Right? You add a new one, you get a new value. And the next round, you either don't add or you have to add. And then by the time when you get 32, the most you can do is add 32 once, and then you will always do the same. Alright, I think this one I understand. Huh. Yeah, let's put it a nightmare. I can solve this. Alright, that'll be it. I'll see you guys tomorrow.